Welcome, everyone. I'm Mike Teeling, and I'll be your moderator for today's webinar, Copilots Boost Developer Productivity, Hype versus Reality. Today's discussion dives into one of the most pressing questions in tech. Are Copilots a genuine productivity boost for developers, or is it more hype than help? Tools like GitHub Copilot, Amazon Code Whisperer, Tabline, and others have gained traction quickly. They promise to ease the workload on developers and enhance innovation by taking on repetitive coding tasks and accelerating problem solving. But today's agenda asks, do they truly make developers more productive, or are they introducing new challenges and complexities? On this webcast, we will discuss the reality behind these claims. We'll explore how Gen AI tools impact developer productivity workflows, the benefits and the pitfalls, and impart some best practices to follow. Our program is expected to last about 45 minutes, including your questions. Now, before we begin, let's cover a few housekeeping items. We'll have a Q&A session after the presentation, so if you have any questions, submit them in the Q&A window. You'll find the button there on the bottom in the toolbar. During this session, you'll see a few pop-up polls. We'd like to know your thoughts. So participation is optional, but we'd love to record your responses, and we'll share those after the webinar. Today's webcast will be made available for your on-demand playback, so please look for the link in your email. Now, with that out of the way, I'd like to introduce Manjusha Matabushi. She's the CTO and co-founder of Talentica Software. For the past 3 decades, Manju has mentored more than 70 startups, helping them build successful products in domains such as fintech, edtech, healthcare, media, and advertising. Talentica is a product development services company focused on helping tech startups and technology companies build and scale their software products. With expertise across AI, blockchain, and the latest technologies, Talentica has provided end-to-end development from product ideation to execution for more than 200 startups worldwide. So with that, let me turn it over and introduce Manju, who will lead us into the heart of today's topic. Hello, Manju.
Thanks, Mike. Thanks for the introduction, and good morning, good evening to all of you, wherever you are. I should say maybe good morning, as it's almost morning for many of us here. Right. So today's topic, as Mike mentioned, is all about productivity gains using Copilot. So before I get started, maybe it'll be good to know, your opinion on whether you think Copilots are a hype or otherwise, right? Maybe we'll take a quick poll, and if you guys can answer the poll question, it'll help. Oh, interesting. So it looks like it's a mixed bag. I mean, some of you think it is a hype, and a few of you think otherwise. But let's get started. Today's presentation, I'm going to be sharing my experience in using Copilot and the observations we made and the impacts or the insights we gained by using Copilot. But before we get into that, I want to talk about the approach we used to kind of roll out Copilot across all our customer teams. Also want to cover the landscape of tools that are available and the ones that we evaluated and why. And then also spend some time on the productivity measure, as that is the base for all our observations. So I tried to make, kind of a tag cloud. I tried to put together a tag cloud of all the tools that are available, but I couldn't fit it into one slide. Then I decided, okay, you know what? Let's just stick to the ones that we evaluated. There are multiple Copilots are available today across the entire product development cycle. And if I look at it from design to deployment, on the design side, we use Figma a lot, and we evaluated builder.ai, which basically takes the Figma files and generates code. We didn't have much success with it, but the tool looks promising. On the development side, there are multiple tools, but we looked at GitHub Copilot, Tab9, Codium, and AWS Code Whisperer. I'll kind of do a deep dive on these in the next few slides. The testing front, Catalog Studio, pretty good framework as helps testing the QA engineers with generating test cases, test scenarios, and helps in automating tests and also run them. But overall, Catalog Studio is pretty expensive, so we haven't really used it across our customers. Test time is something that we have been using, and it kind of works well. On the DevOps side, we haven't spent much time in evaluating these tools, though Jenkins has a plugin that helps us generate the pipelines. We also have, Code Whisperer generate Kubernetes configurations wherever we need. But today's presentation is focused on Copilots for developers, and that's what I'll be talking about. So look at Copilots for developers and the popularity of tools. GitHub Copilot beats all the rest, and followed by Tab9, and then followed by AWS Code Whisperer. There are many claims that people have made regarding the productivity gains that they've seen using these tools. Look at a Gartner report that talks about 55% gain in task completion speed. And GitHub Copilot itself has published the gains, saying that they have seen 55% faster completion of coding tasks. AWS Code Whisperer claims 57% faster completion of coding tasks, while Tab9 claims 30% faster. We evaluated all of these tools, all four of them, the GitHub Copilot, Tab9, Codium, and AWS Code Whisperer. We picked Copilot for three reasons. One, its usability, because it integrates well with GitHub, the source control system. It also has a good coverage of programming languages. It can be used with Java, JavaScript, and TypeScript. Also, does better than AWS Code Whisperer in this regard. The quality of suggestions, that is, be it autocomplete or the chat suggestions, does a very good job of it compared to Tab9. So because of this, we have gone with a GitHub Copilot. We rolled it out across 16 of our customer teams. And then all our observations today is what I've captured here, and then the insights. So the gains that we've seen, or the key takeaways from our rollout across all our customers. To start with, the one observation is that it takes minimum of 3 months to see any kind of productivity gains after starting to use Copilot. Second, the gains vary with product maturity. When I'm talking about product maturity, what I mean here is an early stage product, like a minimum viable product, versus a mature product that has a code base that is older than 5 years, right? So the gains that we saw vary between an early stage MVP, a growth stage where you're building, rapidly building features, versus a mature product that is stable and where you're kind of doing enhancements, bug fixes, and new features. The interesting observation is related to story points, where what we have observed is the story point gains we don't see while using Copilot, and primarily because the story point sizing is itself influenced by the productivity gains. The other thing we measured is the code churn. When I talk about code churn, it's important because it kind of tells us the number of lines of code that people delete, or developers delete with respect to the number of lines of code added. This is important when we look at refactoring bad code, or if you're looking at things like requirement changes. Code churn is an important factor. So we looked at the code churn, and the code churn reduced wherever we have used the Copilot. I think the highest impact that we have seen is on the unit test coverage, where consistently across all our customers, we have seen the unit test coverage improve. So kind of quickly talk about the process we followed to roll out the Copilot across all our teams. We rolled it out across 16 teams in the last 1 year. These teams, product teams, were a combination of early stage, growth stage, and mature state product teams. The first thing that we did was to train all our developers and the test engineers on Copilot. We identified certification courses that they could go through. Today, we have more than 60 engineers who are certified, Microsoft Copilot certified developers. We also created a knowledge base of FAQs that developers could use. And as we started rolling out the Copilot across all our customers, we also kind of documented certain best practices that we could share with developers. The next step was to get customer consent. It was necessary and it's important to get customer consent because of the security concerns with respect to Copilot. And as you all may be aware that Copilot GitHub Copilot requires the code to move to the cloud. And because of this, there were certain concerns and we had to take customer consent for it. But most of our customers agreed to using GitHub Copilot. With the customer consent, we rolled out Copilot to all our developers and the QA team. The next step was to measure or track usage metrics. So in talk of usage metrics, the metrics that we collected was like look at the active users, active sessions, the duration of each session, the chat interactions that they were having with the Copilot, and also the number of auto suggestions, line suggestions that they were getting. Right? So these are the metrics that we captured. And lastly, of course, we wanted to measure the productivity improvements. Now, when we came to this step of measuring productivity, we had a challenge on what should be the productivity measure. So the biggest challenge here was like to identify the right measure for the productivity. So we looked at multiple different methods of measuring productivity. We said, okay, let's look at Copilot, what they have to offer, right? So GitHub Copilot, the metrics that they have two kinds of metrics. One is the quantitative and the other one is the qualitative metric. The qualitative metric basically is a metric they derive by conducting surveys. They look at developer experience, and that really doesn't help us because it doesn't give us an objective measure. So then we looked at the quantitative measures, and the quantitative measures that they provide us are the lines suggested versus lines accepted, the chat turns versus the chat suggestions accepted, and then the overall chat acceptance ratio. They also look at active users, the usage time, and these are all the metrics that were. So if you look at these metrics, the metrics are pointing to primarily the code completion rate and not really the productivity of the developer, because completion speed does not guarantee higher productivity. I might write a lot of code very fast, but the code may not be accurate. The code might require to be refactored and may not meet the requirements. So we couldn't use the code completion speed as a metric for productivity. So then we looked at other measures. We said, okay, we look at DORA. DORA is a very popular metric for productivity. It's good because it measures engineering efficiency. The metrics like, the deployment frequency, mean time to recover. These are all good metrics when you're looking at a product development or productivity with respect to the product. But when you're looking at developer productivity, this doesn't correlate well, primarily because the DORA metrics are very much dependent on the level of automation that you have within the product. So it will vary with an early stage product where you don't have any kind of automation. It is hard to correlate with developer efficiency. So we then looked at SPACE framework. This is another metric that is available to measure developer productivity. But SPACE uses mostly subjective measures such as developer satisfaction, the flow rate, and the communication between the different developers. Now, this again was not useful because it doesn't give us a metric that we can compare. Actually, space also has other metrics, like they do measure the activity, but the activities that they measure are related to the number of commits and the reviews, but those are also not a very good metric for developer productivity. Lastly, of course, we kind of looked at agile metric, the velocity and story points. All of us are very well aware of these metrics. And this is something we have also been using as a measure for productivity for a long time. So we look at team's velocity as a measure to say, okay, the cycle time is improving or not based on the velocity and the story points delivered. But unfortunately, we couldn't use story points as a measure because the story point sizing was very much influenced by because of the productivity gains with Copilot. So we had to come up with another true measure of developer productivity. I'll pause here and then I want to understand from each one of you, what do you all think is the right measure for developer productivity? Interesting. Yeah. So we then went back to the drawing board and said, okay, let's look at it from the tech leader's perspective, right? We said, okay, what is it that the tech leaders are looking for? The first thing that the tech leaders are looking for is features to production. How can I get more features to production faster? So that basically implies cycle time reduction. Second thing that's important to tech leaders is reliability. When I'm talking about reliability, they're looking at the production bugs, minimal production bugs, and reduction in error rate. So we looked at cycle time, and then we said, okay, what are the factors that influence cycle time, right? The factors affecting cycle time, first, of course, is the task complexity. When we look at task complexity, there are two things that come to my mind. One is the algorithmic complexity, that is the complexity in the logic of building the feature. The second complexity is in terms of the impact of building that feature. When I talk about impact, it's from the code perspective, where if I make a change to the code, what is the impact on the rest of the product, right? Product functionality. And this depends on the change, the dependencies across multiple modules, the number of places that you have to make the change. So these are all the impact of making the task complex, right? So when I look at task complexity, 70% of the time you are actually working on the complexity with respect to the impact, that is the dependencies. It's only 30% of the time that you're working on the algorithmic complexity. The second thing that you're looking at is scope creep. When I talk about scope creep, it's basically the requirements, being changed. There are two reasons. I mean, one is scope creep. The other is, it's not necessarily that the requirements change, but it's also related to understanding of the requirements. Many times developers do not understand what the exact requirement is and end up, rewriting the code and because of their, wrong understanding of the feature. Third, of course, is the developer proficiency. When I'm talking about developer proficiency, it is related to the proficiency with respect to the programming language. If the developer is not proficient in a particular programming language, the code written typically goes through a churn because code reviews, recommendations need to be incorporated, and those will require either the code to be rewritten or refactored. And lastly, the code base itself, the code base, whether it is an old code base or new, because if it's an old code base, the developer needs to kind of get an understanding of the full system before they start working on this. So when you look at these factors that affect cycle time, we said, okay, derive a score based on these factors. So we came up with a DevX score. We call it a developer excellence score. And this score is derived from the code commits. So we look at code commits, that is the additions and deletions to the source control system, and look at the churn, that is the in terms of churn due to bad code and scope changes. That is, every time a code is committed, looking at the ratio for a particular feature or particular file, the number of additions versus deletions, we look at the ratios and for each file and then compute an overall code churn factor. The next we look at is the type of the task, whether it is a new feature, enhancement, or a bug fix. Typically, if you see, for any new feature, we end up writing a lot of code. Whereas for enhancements and bug fixes, a lot of effort is spent in understanding or finding the root cause of a bug fix before fixing it. So the number in terms of the code committed itself may be low, but the effort required is higher. And similarly for an enhancement. Thirdly, we look at the module complexity. When I'm looking at module complexity, we look at three things. One is we look at the code complexity through static code analysis. We also look at the dependencies. For each module, we look at the references that this module has with relate to other modules. We also look at individual file imports and then come up with a dependency factor for each file and the module. And then the age of the code base is also considered. Lastly, the programming language. There is a score associated with the programming language. And with all of these, we derived a DevX score and for each developer, right? So the DevX score is at the developer level based on the activities that they have performed and the complexity of the code and the type of task that is being performed and the language of the programming language. This DevX score, we found, interestingly, correlates very well with the story points before the Copilot was introduced. So that is, in a way, whatever the story points were capturing in terms of the complexity, in terms of the effort, the DevX score was correlating well, right? And also kind of, we haven't really matched it with cycle time, but for some of the customers, we have seen that it correlates well with cycle time too. Now, using this score is where we measured all the observations that we made is based on these DevX score. And going back to what I started with, the insights, the first thing that we talked about is Copilot usage. And when I look at Copilot usage, like across maybe 12 to 14 months, the first observation is that the average number of suggestions increased from 1,000 to 2,500 within a week in almost every team. When I'm talking about 1,000 to 2,500, this is the number of suggestions that the Copilot usage wise, right? So these suggestions could be auto suggest suggestions or chat suggestions. Second thing is the acceptance count went up from 425 to 1,000, which means that the acceptance ratio remained the same. That is, the number of suggestions went up and also the acceptance ratio. So the acceptance of suggestions, the overall ratio kind of remained the same. It varied between 35 to 40%. So anything, though the acceptance ratio, the other way to look at it is that though the acceptance ratio remained the same, the usage went up. That is, from a beginner level to a power user level, the developers were able to get more suggestions using Copilot by giving the right prompts and asking for the right things, right? So the next thing that we looked at is the productivity gains that I talked about, that it took minimum of 3 months before we could see any gains, right? So this is how it looked. The DevX score initially in the first 3 months remained almost flat and then it started to increase. But the interesting thing here is that the acceptance ratio of the suggestions still remained at 35 to 40%. What this implied is that the overall number of chat suggestions and accepted to the suggestions remain the same, but the quality of suggestions improved. So the quality of suggestions improved because the quality of prompts also improved. So the quality of prompts had a very high impact on the gains. So the better the prompts, the better the code suggestions were, and then the code that was used. if you look at the product, the productivity gains by product stage, right? So if you look at it from the three different stages, that is the early stage, the growth stage, and the mature stage. Interestingly, the mature stage had the least impact, whereas on the MVP stage had the highest impact. So if you look at the MVP stage, that is the early stage products where we are writing a lot of code, we saw gains anywhere between 50 to 55%, right? For growth stage product, where the product has been in the market for and the code base is about 1 or 2 years old, where we are building features like rapid feature development, we could see anywhere between 20 to 25% increase in productivity, right? Lastly, of course, on the mature stage side, where the code base is old in terms of 5 to 8 year old products which have been in the market, and these products, the gains have been lower, anywhere between 10 and 12%. So the maximum impact that we saw was in the early stage MVP products. Now moving on, I think I spoke about story point trends and that story points not correlating well with the productivity gains. And here's what we see. For an early stage product, when we look at the productivity gains, we saw a flat line in the first 3 months, and then the productivity increased in the next 4 months. And similarly, if you kind of look at the story points estimated by the same developers, it kind of remained flat. And the reason for this is because when the developers are estimating a task by story points, they're looking at the effort required to complete that task. And when they're looking at the effort, since with Copilot, now the effort is lower. So the estimation of the story point, the number of story points is also lower. So the sizing got very much influenced by the productivity gains, right? But if you look at it in the mature product side, it did not influence much. The reason for this is the productivity gains were lower. So the story points also did not kind of change much in this case, or we didn't have enough data to kind of see whether there's a good correlation. But overall, on the mature product side, we did not see the story point sizing getting influenced much by the the productivity gains. So if I look at it as in summary, our entire the gains that we saw across all our customers took 3 months to see any kind of productivity gains in teams using Copilot. On an average, we saw between 20 to 25% across all the teams in terms of the productivity score. And we could see that a beginner user, the gains were around 5%, and power users, the gains were around 20 to 25%. In an early stage product, like where we are doing writing a lot of code, we saw an improvement of 55%. And when it came to mature products, it was anywhere between 10 to 15%. Interesting thing was on the churn side, the churn surely reduced, and the churn was around 11% lower than before. And the highest impact, like I said, was in the unit test coverage. Consistently across all our products, wherever we used Copilot to generate unit test cases, unit test coverage went up from 20 to 70%. So all of this had a few things that required us to do, and I think these are the best practices that we have come up with. And first thing is that whatever the suggestions that we get from the Copilot have to be reviewed, and the code before accepting that code changes, right? So many developers today, they don't accept the entire suggestion. They copy paste the part that is relevant, and so that reduce the amount of refactoring that they need to do. Second, to look at the code from a security and compliance perspective, because you want to make sure that there are no vulnerabilities in the code that is being suggested. Thirdly, of course, one interesting fact that we learned is if a particular prompt requires us to generate code across multiple files, we need to keep all those files open so that the suggestions given by Copilot are kind of correct when it comes to all the changes, so that we don't have to copy paste individually in each file, but we kind of get relevant changes for each file when it's kept open. Lastly, and the most important, is the smart prompts. What we did here is we have compiled a set of prompts for different tasks. Like, for example, if you want to generate you want Copilot to generate a SQL query, we have a prompt on how to ask for that SQL query. Similarly, if you want to write an API, we have a prompt that says, what all aspects of the API should be part of the prompt. So these are all, we have compiled around 25 to 30 such prompt templates that we have shared with all our developers. As a next step, we are looking at quality copilots for quality. We're looking at, Copilot. We are building a Copilot for PR reviews to improve the time taken for PR reviews and also for functional testing. We also have a security Copilot, which looks at vulnerabilities, mainly CVEs, and provide fixes for the same. We're also looking at open source Copilots, primarily because of some concerns that some of our customers have with respect to GitHub Copilot. That's all I had for today's presentation. Yeah, and Mike, handing over to you.
Great, great. Well, thank you. Thank you so much, Manju. That was excellent. Lots of really good, valuable insights for the audience, I think, from Talentica's direct experience with some of these tools. So that's great. We do have some questions that have come in, so maybe we can run through those in the time that we have left.
Sure.
Okay. The first one is, maybe you can talk about what are some of the security concerns with GitHub Copilot?
Yeah, so main concern with GitHub Copilot is, the code moves to the cloud. So one of the concerns that most of our customers had was, will our code, be used for training? So we checked the Copilot license, and Copilot license clearly states that they will not be using the code that we share for their training purposes. So that is one thing that is guaranteed. But I think the other option that our customers have is the enterprise license, where where GitHub guarantees that their code is not visible or to external users, so their code is protected. So these are the two things that helped us kind of convince our customers that it's okay, safe to use, go with GitHub Copilot. Yeah.
Okay, great. Thank you. Next question. Were the story points defined by developers or by the product manager or who?
Yeah, so that's an interesting question because, in early stage products, typically there are no product managers, and it's the developers that end up estimating the story, estimating tasks, and they do get highly influenced by the productivity gains. Whereas in mature products, where there are product managers, there the product managers do the estimation, but even in those cases, it's typically the product managers sit with the technical team to do those estimates. But we didn't see the much of an influence on the mature product side, primarily because the overall productivity gain itself was lower on the mature product side. I think if we get better at the way we do the prompts and we look at, maybe training or fine tuning the copilots with the code base, we might see better gains. But as of today, for mature products, we don't see that much gain. And also, from a story point perspective, we don't see the influence also. Yeah.
Okay. So here's the next question. Which open source version of Copilot did Talentica specifically try?
Still exploring, but I think the one that we are looking at seriously is Code Llama, and Code Llama looks interesting, and that's the one which is open source, and we are currently evaluating that. Yeah.
Okay, great. I think that's the last question, unless anybody else wants to put one in real quick here, but I think we've reached the last one. So I really want to thank Manju and everyone else for joining us here today. This concludes our program and discussion of Copilots boost developer productivity, hype versus reality. A huge thanks to Manjusha Matabushi and Talentika for sharing their insights and their experiences with us, and to our audience, to you guys for all your participation and your thoughtful questions. So keep an eye out in your email for a follow-up from us with a link to the webcast playback and details on how to connect with us here at Talentika. So we look forward to seeing you all in our next session. And with that, I'll just say goodbye. Thanks.
Thanks, Mike, and thanks everyone for joining this webinar.